All right, let's jump right into this explainer and decode the multi-billion-dollar reality of the flying taxi race. Today, we're moving way beyond the sci-fi hype and looking at the cold, hard data, the actual physics, and the corporate titans battling to own the skies above your city. We're going to narrow down exactly who the major players are, how they plan to pull this off, and why the future of your commute is literally being rewritten as we speak. Picture your daily commute for a second. The stop-and-go traffic, the endless red lights, the absolute frustration of gridlock. Now ask yourself, how close are we to skipping that traffic entirely and just taking to the skies? I know, it sounds like something straight out of an old cartoon, but the reality is that the timeline to your first electric flight is no longer measured in decades. It's measured in just a few short years. So, just how close are we? Well, to understand that, we have to look at the epic scale of the giants currently shaping this brand new industry. We're tracking a projected $94 billion urban air mobility market that has actively pulled in the absolute colossuses of the aerospace and automotive worlds. This isn't just a handful of scrappy startup founders tinkering with drones in a garage. And the financial stakes? They are absolutely massive. Over $10 billion have already been invested by industrial heavyweights to guarantee these aircraft actually make it to market. These huge capital injections from global automotive and aerospace groups are designed to ensure continuity. They're making sure these projects don't just run out of cash and disappear, which, let's face it, is a pretty common fate for independent startups. They are completely 100% committed to this. Section 1. The Physics of Flight, Overcoming the Hover Challenge. Before we look at the specific companies fighting for your commuter dollars, let's learn something new today about the actual physical constraints that make building an electric air taxi so incredibly difficult. It's definitely not as simple as just slapping wings on an electric car. The P of hover formula, which calculates the energy needed for vertical takeoff, shows us that the power needed to just hover in midair grows exponentially with the weight of the aircraft. Because current batteries are incredibly heavy, to lift those batteries, you need more power, which means you need more batteries, which adds even more weight. It's a massive engineering hurdle demanding incredible advancements in battery efficiency just to make these vehicles commercially viable. Section 2. The Manufacturing Muscle. Silicon Valley meets Detroit. Let's see how these companies are overcoming those exact physics challenges to actually manufacture these highly complex vehicles at scale. Because, as any engineer will tell you, building one prototype is hard, but building hundreds flawlessly is a totally different game. And the crucial point here is funding. California-based Joby Aviation is currently leading the pack with a massive $976 million war chest. They're followed closely by their U.S. rival, Archer Aviation, with $550 million. Meanwhile, Europe's Lilium, which utilizes a highly innovative but complex electric jet design, is racing against a much tighter budget of $350 million. In the aviation industry, cash equals the runway you need to survive regulatory certification. But hey, having cash isn't enough. You need serious manufacturing expertise. To build hundreds of aircraft a year, Joby is leaning on the legendary Toyota production system, with Toyota engineers actively designing their California facility layout. Archer is taking a very similar path by teaming up with automotive giant Stellantis. They're currently building a massive 100-acre facility in Covington, Georgia, that's fundamentally designed to produce up to 650 aircraft annually. This is the true industrialization of the flying taxi. Section 3. The Autonomous Wildcard. Boeing's Secret Bet. While companies like Joby and Archer are sprinting to market with conventional human-piloted aircraft, there is a dark horse taking a completely different, much riskier path. Let me pose a fascinating question for you. How does the entire business model of an air taxi change if you remove the human pilot from the cockpit entirely? Think about the weight you save, the salary you don't have to pay, and the training you can skip. We can directly contrast these two philosophies. You've got Joby's S4 Nautil, which fits 4 paying passengers and 1 highly trained pilot, aiming for a 2026 launch. Then you have Wisk Aero, a company backed heavily by Boeing. Wisk's Cora aircraft sacrifices short-term capacity, holding only 2 passengers, and pushes its launch into the 2030s. Why? Because it's fully autonomous. While Joby gets to market faster, Wisk is betting that eliminating pilot salaries will create a system with vastly lower long-term operating costs, ultimately winning the marathon. Section 4. The Global Contenders, Emerging Ecosystems. While the heavily funded U.S. companies dominate the headlines, we absolutely have to look globally to see who is quietly building their own powerful ecosystems. The future of urban air mobility isn't just an American story. A massive explosion of aerospace talent is currently happening in India. Driven by legendary urban traffic congestion, India is rapidly becoming a major player. You have AutoSync Aviation acting as the primary domestic eVTOL developer. You have drone giants like IdeaForge with incredible autonomous manufacturing capabilities. And you have Sarla Aviation targeting a launch as early as 2028. Sarla recently proposed an air route to the Bengaluru airport that would cut a grueling 152-minute road commute down to just 19 minutes. That level of time saving is absolutely world-changing. And let's not count out the UK, a staggering $850 million. Vertical Aerospace, a British company many thought was running out of time, just secured this massive funding lifeline. This pushes their Rolls-Royce-powered hybrid electric aircraft firmly back into the global race. It's a perfect reminder that in this highly competitive space, one major capital injection can completely rewrite the leaderboard. Section 5. Who will actually win? The timeline to take off. With all these different strategies, all these deep-pocketed partners, and regional contenders springing up across the globe, the ultimate question remains, who actually wins, and when does this race cross the finish line? Well, the hares in this race, like Joby launching in Dubai in 2026 and Archer and Lilium following in 2027, will establish the very first commercial markets. They're going to do the heavy lifting of getting the public used to flying in small electric vehicles. But then we have the tortoise of the race, Wisk Aero. By holding out for the 2030s, they are playing a strategic long game, banking entirely on the belief that a fully autonomous, pilotless network will be the ultimate, most profitable winner in the decades to come. Which brings us right back to you, the future passenger. It leaves us with one final provocative question. When the time finally comes, are you ready to trust an entirely pilotless flying taxi for your daily commute? It's an incredible shift in how we move, and it's happening right now. And with that, I want to sincerely thank you for joining us on this Explainer today. We love breaking down these massive technological shifts for you, and I hope you learned something entirely new about the skies above you. Stay curious, and we'll see you in the next one.